Hello everyone, welcome to another video, and today we're going to solve a new question called power of x to power n. And as you see see my screen, the question asks that we have to implement a function called POW, and that POW will take two arguments, like one is x and second one is n. X is the number and n is the power, and then we have to return x to the power n. So in brute force approach, we can just write a for loop from 0 to n, right? And then for every iteration we just have to keep multiplying the same number and we can return the value. But there is a trick here, so let me explain that on the whiteboard. For example, the trick is, like, for example, we need to calculate 2 to the power 10. Okay, now the thing is that if we calculate 2 to the power 2, then 2 to the power 4 will be 2 to the power 2 cross 2 to the power 2, right? So if you calculated 2 to the power 2, we don't have to recalculate 2 to the power 4, we just have to get 2 to the power 4 by multiplying 2 to the power 2 with it. Same way, if you want to calculate 2 to the power 8, it will be 2 to the power 4 into 2 to the power 4, right? And then the same way, so the number of operations is decreased substantially. Rather than calculating 2 into 2 into 2 10 times, now we just calculating 3 times and we already get 2 to the power 8, and we just have to take care of extra 2 to the power square, right? Let's see how we're gonna do it. For example, if we create a function, right, we're gonna keep track of our result, right? Let result is 1, and then our function will take the n, that is 10, right? It will take n, okay, and then it will keep calculating our multiplication, or our the product equals to our x into x, right? That is, we can say, or we can create x equal to x into x, right? And then we have to do n equals to n by 2, and you're going to feed to the same method. And if n by 2 is not, if n is an odd number, then we have to take care of the extra 2, and that we're going to take care with the result. So result equals to x into result. So what's going to happen here in this particular case, if for example n is to 10, so first time it's gonna our n is 10 is even, right? So it's not gonna do anything here, so it will calculate our 2 square. Second time n is 5, so it's gonna go here, and our result will register 2 to the power 2, because it will be x, that is x, and sorry, this one 2 to the power 2, right? So this will become, then again at that time our n will become 2 to the power 4. This one, this x will become 2 to the power 4, and our, then the same way we're going to n equal to n by 2, this will become 2, right? Sorry, it was sorry, 5, then 5 by 2, it will become 2, and it will go here. Then this time this is a even, so we're not going to do anything to our result, and 2 to the power 2 become 2 to the power 4 become 2 to the power 8. Now again it will become 2 by 2, that is 1. Again we're going to give it. So what's going to happen here, result, now this is odd, so previously we have result 2 to the power square. 2 to the power square into 2 to the power 8. So result already become 2 to the power 10, and that's it, because it's now, again, if you divide 1 by 1, it will become less than 1, so we're gonna anyway break it. So by the time when our n become less than 1, our result will be containing the final output. So this is the same logic we're gonna write using JavaScript. So let's do that. So first thing we're gonna create, not here, so function pow, we're going to create a JS file first, .js. Now function pow, oh my god, function pow, x and n, right? There is another condition I forgot to mention. If n is negative, it means we just have to calculate we just have to return 1 by that particular result. So we don't have to worry about it. We just have to calculate our result anyway in both cases. And when n is negative, while returning the value, we just have to make it 1 divided by the result we derived anyway. So first thing first, here we have to put our case, like let first we're going to declare our values, like let result equals to 1, and our x anyway we don't need, and let's give a new number, like product equals to x. It's going to start with x. Then we're going to create a new function so that we don't have to mess it up. Okay, then now function calc, and it will take our n, right, and it's going to calc the same function with math.floor n by 2, and if our best case will be like if n less than 1, we're gonna break it, return. So our base case and our n by 2. Now that we're gonna decrease the n by 2 is done. So now we have to write our logic that if n by 2 not equals to 0, means it is odd, then we have to calculate our result, right? So result equals to prod. So we're gonna make our product, we're gonna multiply our product with the result, and if not, we're gonna anyway calculate our product equals to, we're gonna multiply product with product and save that into the product. That's the whole logic, I believe. Then we have to take care of our that case, that if it's a negative, right? And by this time, when the n become less than 1, our result already will contain the needed power. Then now we have to calc. We will call this method, right? Calc math.abs absolute, because we are sending, we don't have to worry about n is negative or positive, so we are sending the absolute value, so we don't have to worry about it. Sorry, perfect. Yes. Now then, when this method get called, our result will be having the value, but now we have to check for the negative condition. So if n less than 1, return 1 by result. Okay, if not, return result. So this should solve our question. Let's check in the Leet itself. Did we copy it? Copy this and then go here, paste it. Then we're gonna run our tests. Run. Perfect, everything is passing. Then we can submit. Fine. You see that this is one of the most efficient solution here. So thank you for watching.